What's going on, everybody? Got another video here for you. This one is wxMaxima, and we are going to go through this, and we're going to do quite a bit of stuff with wxMaxima. It's going to be several videos, probably a lot of them. This is the first one. We're going to go through calculus and all that stuff, but we're going to start with the basics and work our way up. So this one right here is basic operations. We are going to look at, for the basic operations, we're going to look at arithmetic, algebra, and some trigonometry in this one. All right, so let's get started. So the first thing, let's just evaluate a simple expression. This is wxMaxima. So let's suppose we want to evaluate 4 times 2 plus 5. So we just type in 4, and then you do the star, shift 8 for the star, so times 2 plus 5. Okay, and when you enter that, you have to put a semicolon at the end. Okay, and then to get the actual number, you have to hold shift and then hit enter, and then you can see right here this percent I1. That's your endpoint. That's your input 1, and here's your output for 1. It's 13. Now, let's suppose that we wanted to add the square root of 3 to this number. Okay, add the square root of 3. So we could type in 13 plus square root of 3, or square root of 3 plus 13. It doesn't matter. But one way we can do it, since we want to add square root of 3 to this number here, what we can do is we can put percent. And what that's going to do is that's going to recall your last answer. Okay, and then we just put plus. So this percent sign here represents the 13. That's our last output. And then I'm going to do square root of 3. And then don't forget, you need to put the semicolon. And we're going to hold shift, enter. And what does it do? It puts square root of 3 plus 13. All right. So, we can, that's technically what it is. But if we want the decimal answer of it, if we want a decimal answer, we can type float, parentheses, and we want the decimal answer to this square root of 3 plus 13. That's the last output. So we'll put percent. That's going to recall that last output. We put a semicolon and hit shift, enter. And there you have it. And then from there, if you want to, you can take that number and you can square it. So we can do percent. That's going to recall that last number, that last output. And you do the little house top, the little caret, and squared. Or you can cube it. You must cube it. We can do whatever we want with it. And then we're going to put the semicolon and shift, enter. And then it cubes 14.73205. It cubes that number. Okay. All right. So the next thing we can do is we can add fractions, subtract fractions. So let's add some fractions. Let's add 5 over 6 and 7 over 15. All right. So we want to put in parentheses 5 over 6. That's going to treat that as a single term. Okay. And then we put plus, and then we've got 7 over 16. And we have to put that in parentheses, 7 over 16. And then we have to put a we got to put a semicolon at the end. I think I did that right. Yep. And shift enter. well, 7 over 16. I think we can actually might come up here. I wanted to do 15. Let's do 15. And let's do Shift Enter. And see, if you make a mistake, you can go back, change it, and it redoes it. Now, notice when I did the first one, it had the I5 and O5. But when I redid it, it changed it to I6, O6. Okay, so it did affect the numbers. All right, so that gives us the reduced fraction. That gives us a fraction as an answer, and it reduces it for us. And if we want the decimal answer, what do? Well, just like in the previous, we do float, and then we can do percent, and we do percent to recall that last output, 13 over 10, and we hit Shift Enter, and there it is, 1.3. Okay. All right. So now, what about E? What about E? You know, E 2.7182818 and so on. All right. Let's calculate that. Let's figure out what that equals, what E equals, and then let's find the natural log of E. Well, we know the natural log of E is 1. Let's see how we do that in wxMaxima. All right, so I'm going to do float because I want E as a decimal. And the way that we enter E is with a percent and E. That represents E. All right, and we do float that, and that should give us a decimal as an answer. So I'll put my semicolon, Shift Enter, and there you have it. Okay, now what if I want to take the log, the natural log of E? Well, for the natural log of E, wxMaxima for natural log, you type in log. Okay, so we want the log of E, so we want the natural log of E, so we type in log, L-O-G, and then we do percent E. That's going to give us the natural log of E. And we put a semicolon and then Shift Enter, and we should get 1 as an answer, which we did. All right, so now let's look at some algebra. We got some, the basic arithmetic operations. We know how to add fractions. We can simplify fractions in the same way and all that good stuff. And we know how to evaluate expressions and that kind of stuff. So let's do the algebra part of it. So let's simplify an expression. So what if we have the expression 3x plus y, okay, and we want to add 2 times, let's do 2x minus y, 2x minus y. Oh, I hit the wrong 2x. Did I type that in? No, that's it. Minus y. All right. Now, look how I typed this in. Well, this is not the correct way to type it in. Do you see here how we have 3x? You can't type, if you have 3x, you can't type that in wxMaxima. It doesn't recognize that as 3x. You have to actually type in 3 star x. And so we would have to come in here and put 2 star and then 2 star here. And then we hit the semicolon, and then we're going to hold Shift Enter. And look what it gives us. It gives us y plus 2 times 2x minus y plus 3x. that's not really what we wanted. We wanted to simplify it even more, maybe even combine like terms and all that stuff. So let's do that. And how do we do that? Well, we do rat simp. Okay, and what do we want to simplify? We want to simplify the previous output. So in parentheses, we put the percent sign. That's what we want to simplify, that previous output. And we put a semicolon, and then we hold shift, enter. And you can see we get 7x minus y. And that simplifies it all the way. All right, so what if we wanted to factor something? Okay, what if we wanted to factor a quadratic expression? Well, it's pretty simple. We would type in factor, and in parentheses, you just type in what you want to factor. Let's do x squared, x squared minus x minus 2. I know that's a simple one to do. Okay, and then let's hit our semicolon, and then we're going to hit shift enter, and you can see there it factors it for us. X minus 2 times x plus 1. All right, so let's look at some more stuff that we can do here. What about adding rational expressions? Okay, let's see about doing that. What if we wanted to add, okay, let's add, how about 5, let me get this down so we can see what we're doing. 5 divided by x squared minus 1, close parenthesis, plus, and then let's do x minus 2 over, let's do x squared plus 2x minus 3. All right, so let me ask you this. Is everything typed in correctly? Okay, did we type in everything right? We didn't, did we? Remember, the 2x, we've got to put that in as 2 and then the star x. And then we mash the, we do the semicolon and then shift enter. And that's what it gives us. Okay. I mean, it looks good. We can see that we typed it in correctly. Okay. Now let's do rat simp of that previous output. So rat simp, and then we've got percent. All right, and semicolon, shift enter, and there you have it. You see how it does that? All right, now what if we wanted to write this out as it being factored? Everything's factored. The numerator's factored, the denominator's factored. Well, the numerator doesn't factor. We can probably just look at that and see. But what about that denominator? It might factor. Might be nice to factor that if we can. So let's try it. So it's easy to do. Just type in factor. And we want to factor that last expression. So factor percent, semicolon, and then shift enter. And look at that. The numerator didn't factor, so it didn't factor it, but the denominator did factor. Okay. All right, so what about a complex fraction? Do we know what complex fractions are? Yeah, we know what those are. So let's look at this complex fraction here. Let's see what we get here. So we're going to do, in the numerator, sometimes it helps just to put parentheses first. So let's do 2 x squared, 2x squared plus xy plus x times y. All right, so I've got that in parentheses, divided by y. All right, so look what I have here. So all of that in parentheses, that's the numerator of my complex fraction. And then in that numerator, I have another fraction within itself. And so now let's do the denominator. So I'm going to do parenthesis. All right. Now I'm going to have a fraction in the denominator. So in parentheses, for the numerator of the denominator, I'm going to have x times y plus x, and then that is going to be divided by y squared. And hopefully I typed all that in correctly, and we're going to do Shift Enter, and that's what I have. And you can see how what it did there. It did something kind of, I don't know if that's weird looking or not, but let's look and see about maybe trying to, oh, wait a minute, let's see. I left off a parenthesis right here. I wanted this to be in parentheses, and so that means, see, that's one good thing. You can go back and look. So let's see if that's any better. Oh, and I forgot to put, I don't have a division symbol right here. All right, so, I'm not perfect doing all this the first time, but there we go. There we have it. So I know what the problem's supposed to look like, but it's just kind of, I know what the problem's supposed to look like. And when I entered it, I looked at it and said, well, I didn't do times. So I just went back and kind of looked right in here and kind of said, okay, well, where did I go wrong? So that's going to happen. Okay. All right. Now, that's what we get when we enter it. Now let's see about simplifying it. Let's do rat simp and that last output, and put our semicolon, Shift Enter. And let's see, what did that give us? Oh, look at there. That made it a lot nicer, didn't it? You see that? So, there you have it. And we could even go further with this, because we see we have a common factor in the numerator. We could actually, let's factor it. Let's write it. I mean, I guess this would be fine if your teacher likes that. But let's look at this. We're going to do factor, and we're going to factor the previous one. Then we've got Shift Enter, and there you go. It factors the y out for us. All right. So now, what about trig? Let's look at some trig stuff. Okay. So let's evaluate the cosine of 85, and then let's do tangent of, I don't know, maybe 5 pi over 6 or something like that. Okay. All right. So we want to calculate the cosine of 85 degrees. Okay. Well, to put angles into wxMaxima, they need to be in radians. Okay. So the 85 degrees, we need to get that in radians first. So how do we do that? Well, remember, radians, that to convert that, you multiply the degree measure by pi over 180. So we've got 85 times pi. Now, how do we do pi? Well, that's percent pi. That's pi. And then we're going to divide that by 180. Hit our semicolon, Shift Enter, and there we have that 17 pi over 36. So that's nice right there too. That if they ask you to convert degrees to radians, you just type it in here and it gives it to you in terms of pi. All right, but our goal here was to do the cosine of that. So what do? We do cosine, parentheses, percent, because we want to do the cosine of the previous output, and shift enter. Uh-oh, what happened there? Well, it just gave us cosine of that. Well, what would we do? Well, we would do what? Float, and then the previous. And shift enter, and there it is. Okay. Now, I mean, we went through a lot there. We did cosine, and then we had to do the float. But what if they just go ahead and give us the angle in radians, and we want to do the tangent of 7 pi over 6? Well, we could just type that float, okay, and we're going to do tangent of what? Tangent of 7 times pi over 6. And I guess it closed the parentheses for me. Yep, it did. All right, and then hit shift enter, and there's your answer. And it goes ahead and gives it to you in the decimal form. Now, what we could have done up here where we did cosine percent, we could have put float cosine percent and got the decimal. Okay. All right. What about working with trig expressions, trigonometric expressions? All right. What if we want to, let's look at trig reduce and trig simp. Okay. All right. So let's just look, everybody knows sine squared plus cosine squared. Sine squared x plus cosine squared x. Let's see what trig reduce does to that. Trig reduce, that is going to be, so we got to do sine squared. So in parentheses, we're going to have sine of x, okay, sine of x. Now all of that is squared. So to do that, we got to put the whole sine x in parentheses, and then we've got to square it. I've got one too many parentheses here, so let's, oh no I don't. We've got trig reduce. We're going to put that in parentheses, and then we've got sine x squared. I think that might be right. Well, if we make a mistake, we make a mistake. Plus, and then we're going to have in parentheses cosine x, and that's going to be squared. And then we need to close the parentheses there. Let's see what we got. I don't know. Okay. Let's see. I don't have the right number of, I think maybe that'll get it. 1, 2, 1, 2. Let's see what we get there. There we go. Is that? Yeah, there we go. So let's look and see what that did. That looks kind of weird, doesn't it? What is that? Well, if you notice this right here, this sine squared and this cosine, well, this would be the sine squared and this one would be the cosine squared. What did it do? It reduced it to its half angle identities, didn't it? You see that? Well, we know sine squared plus cosine squared is 1. So let's do trig simp. Whoop. Trig simp, and let's see if we can let's see what this does. I've already typed it in one time. What if we select all that, hit control copy, put right here, and control Well, it's not letting me paste it, is it? Let's do, okay, so maybe we gotta, I was trying to hit my my keys. Let's do copy, and then what if we come here and hit paste? There we go. So we just copied and pasted it. And then let's do shift enter. Oh, I misspelled trig, didn't I? Trig, and then shift enter, and it gives me 1. Okay. All right, so there's that. There's trig reduce, trig simp. So now what we want to do is let's express sine squared x in terms of a double angle. Okay, so basically what it's going to do is it's going to do what it did up here. I mean, you know, you got half angle identities, or you can just you can express it as a double angle. Okay, you're probably familiar with that. So to do that, well, it's just what, trig reduce, and in parentheses we're going to have sine x squared and semicolon and shift enter, and there it is. We get 1 minus cosine 2x over 2. All right, now last example, let's you remember your sum and difference identities, like cosine of a plus b, cosine a minus b, sine a plus b, sine a minus b, all that stuff. Let's expand that. Let's see if it'll expand that out. If we put in, let's do trig expand, and I don't know, let's do sine of x minus y. Okay, and semicolon and shift enter, and there you have it, sine x cosine y minus cosine x sine y. All right, so I'm going to call that a video. I mean, it's just the basic operations, but we went through quite a bit of stuff. The video's kind of getting long. So we'll do this, and we will do other ones, going through more things and work our way up to calculus and through calculus. And hopefully y'all will enjoy these videos. But I appreciate you watching. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.